And finally, to end this lesson, we're going to be talking about the area perimeter of squares, rectangles, and triangles on a graphical plane. So you've seen at least every formula for these shapes at some point, with the area of a square or rectangle being side squared. For a square, length times width works for either squares or rectangles, and base times height works for either squares or rectangles. You cannot apply the side squared formula to a rectangle as every side is not the same for this shape. For the perimeter of a square or rectangle, it can simply just be written as the sum of all side measurements. We're looking for the total length of the outside of a square or rectangle when we're talking about this. Nothing inside the shape for the perimeter, we're referring to everything outside of it. With this in mind, make a note to yourself below that the area is everything inside of the shape, whereas the perimeter is everything that surrounds the shape. Again, the perimeter is nothing inside, just the measurement of the outside, while the area is focused on the space within the shape, nothing outside of it. The same thing can apply to the area of a triangle. The area of a triangle has one formula and can be written as 1/2 times the base of the triangle times the height of the triangle. Now, again, this should look familiar, base times height. We've just seen this for squares and rectangles, and that's because in every square and rectangle, you can draw exactly 2 different triangles. So if for the entire rectangle, to find the area, it's base times height, then to find the area of half of the shape, or one of those triangles, you have to divide it by 2. That's where this formula comes from. We're looking for half of the area of a 4-sided shape. And like these shapes, the perimeter concept remains the same. The perimeter of a triangle is just the sum of all side measurements. Just the sum of everything outside of it. So when we're talking about the area of a triangle, again, we're talking about everything inside of the shape. This next part is tricky. When we're looking at the perimeter of a triangle, we're still looking at everything outside of the shape. So you may see a dotted line like this at some point when you're looking at triangles. This doesn't count as part of the perimeter. What this is indicating to you is the height of your triangle. Not anything to do with the outer edges of the shapes, just telling you how tall your triangle is in the picture. Make sure you remember that as we get further into these lessons. Moving on to some examples now. Let's find the area and perimeter of the following shapes. Right here, we have a rectangle, which means that for our area, we can focus on the base times the height. And in this case, our base is 60 meters, and our height is 30 meters. So substitute in these 2 values to your formula, which means instead of base times height, your area formula should be 60 meters times 30 meters. If you plug this into a calculator, your value for the area should be 180. But take a look here at your units. We have meters times meters. So when you have 2 units being multiplied to each other twice in a formula, we write our units as meters squared. We treat these as we do with variables. When variables get multiplied by themselves each time, we square them then, which means that for units, we have to do the same thing. When you're working with area, you should have the units squared every time. Now for the perimeter, we're not told that every side here is equal, but if you want to check my graph, you can see that each side is equal based on these squares on each side. So I could say the left is congruent to my right, and I can say that my top is congruent to my bottom. So since my left is 30, my right is 30. And since my bottom is 60, my top is 60 as well. Now for the perimeter, all you need to do is add up every single outer edge. So you should have 60 meters plus 60 meters plus 30 meters plus 30 meters. An important thing to note here is that unlike up top when we were multiplying our 2 meters together to get squared, we're only adding these measurements together. So in the end, you should still just have meters as your unit. They should not be squared. So if I add 60 plus 60 plus 30 plus 30, you should get about 180 meters as your answer. Again, not squared. When you have the perimeter, your units should just be left as given. And that's how you find the area and perimeter of a rectangle. For a square, since it is a square, we can assume that the left is congruent to the right and the bottom is congruent to the top as well. All sides are equal to each other. So the top measures to 7 millimeters and the right measures to 7 millimeters. So let's start with your area. Remember I mentioned earlier, the formula for a square's area can be written as side squared, which means all you have to write is just 7 millimeters squared, which means your area is just 7 times 7 to get a full answer of 49 millimeters squared. That would be your area. We do side square, plug in your side measurement, which in this case was that 7 to get the full 49. Now for your perimeter acts in the same way that we did for the rectangle. It's just the sum of every outer edge listed. So you have 7 millimeters plus 7 millimeters plus 7 millimeters plus 7 millimeters. And if you add all 4 of these together, your answer for the perimeter is going to equal 28 millimeters in total. Remember, when it's perimeter, your units will stay just like that. And finally, let's practice the triangle. Now for a triangle, our area formula is 1/2 base measurement times your height measurement. And in this case, your base is 35 and your height is 70. Now if you can see here, we have to multiply these to each other. Plug them into your formula and you should have 1/2 times 35 inches times 70 inches, which means you should be taking half of 70 times 35 which is 2,450. And if we were to take half of 2,450, of 2,450 is about 1,225 inches squared. Do not forget those inches squared. Again, it is area, so we have to make sure that our units remain squared in the final answer. And for perimeter, this one's tricky. We were not given our hypotenuse for this. So we actually need to do a little bit of extra work to find this missing side right here. We have to use the Pythagorean theorem. So, find your missing side. Your missing side C is equal to the square root of 70 squared plus 35 squared. So if we do this, 70 times 70 is equal to 4,900. And 35 times 35 is 1,225. Adding those together, you'll get the square root of, for those two numbers added together, which gets you a sum of 6,125. Taking the square root of 6,125, you will get a decimal, but we need it if we're going to find our perimeter here. Your decimal should be about 78.26, and that's me rounding to that hundredth spot. That is what your missing side equals, 78.26. So finally, for your perimeter is just 70 plus 35 plus 78.26. And adding those together, it's 105 plus 78.26. Your perimeter should be 1,083.26 inches. Because again, it is a perimeter, so we have to include our units as given. So that's how we find the area and perimeter of basic shapes, but what if we're told that we need to graph them? Let's start applying that into what we like to call coordinate geometry, where you're given coordinates that you have to solve for when graphed. So as we can see here, we have to find the area and perimeter of these shapes. We have A is -1 and 1, B is 1, 3, and C is 1, -1. So if I were to do this, we need to first graph our coordinate points. So draw a little coordinate plane on your notes, just like this, with A being at -1, 1. So you should be in the upper left quadrant of your graph. B is at 1, +3, so top right quadrant of your graph. And C is 1, -1, so bottom right quadrant of your graph. This right here is your graph shape. So we're working with a triangle, which means we're going to be working with the area as 1/2 base times height and summing every side. First things first, let's find the length of AB and AC. Easiest way to do this is, like in the distant notes, we're going to draw our two triangles outside of these points. So I'm drawing my vertical heights first and my horizontal lengths. So as I can see here, to get from A to B, I have to go up 2. To get from A to C, I have to go down 2. And since I go down, I do a negative. Next, I have to go to the right exactly 2 to reach B. So I do a positive 2. And same thing here. When I reach the bottom left corner, I have to go to the right 2 to get to point C. So the length of AB is equal to the square root of 2 squared plus 2 squared. This being my vertical, this being my horizontal. And if I square each 2 and add them together, I have 4 plus 4, which means that I need to find the square root of 8. That is your length for AB. So for AC, we have the square root of negative 2 squared plus 2 squared. Even though this is a negative right here, you will still have the same values under your root as in the length for AB. Your radical should look like this, 4 plus 4, which again means that your length for AC is equal to AB at radical 8. So since we know they both are equal to each other, you're allowed to add the congruency marks on either side. We know what both measure to, and now what we can do is we can say the length of the other side as well, from B to C. From B to C, it has a length of 1, 2, 3, 4. We have a total length of 4 for BC. Now we can start solving for area and perimeter. For your perimeter is just every side added together. The length of AB plus the length of AC plus the length of BC, which means we have the square root of 8 plus the square root of 8 plus 4. Now, it is important in this case to get the square roots in their actual decimal value. So the square root of 8 equals about 2.83 when rounded to the hundredth. So 2.83 plus 2.83 plus 4, your perimeter is equal to 9.66 when rounded to the hundredth. Now, notice how we were not given units for this. If you are not given units, you do not need to include it in your perimeter or area. Let's end with the area formula. So for the area, we can do 1/2 base times height. Now in this case, I want to avoid working with these radical measurements. So I'm going to declare BC to be my base. 1/2 times 4, which means that my height is from point A down to segment BC. And the length from A to BC is about 1, 2. So your area for this is 1/2 of 8, which means you should have a value of 4 as your area. So in this case, your perimeter was larger and your area was smaller. Both of these answers were gained through the distance formula of some sort. Let's move on to the next part. Again, we're given 4 coordinates with this. We're told that we have point J at 0, -2, point K at -3, -1, L at -1, 5, M at 2 and 4. So first things first, draw your coordinate plane. It doesn't have to be perfect, Just make sure it's nice and big so we can work with it. So I'll start with J. J is at 0, -2. K is at -3, -1. L is at -1, +5. And M is at 2, 4. 1, 2, 3, 4. Now, we're working with a rectangle here. Since we're working with a rectangle, and none of these sides pass nicely through my squares, we have to find the distance of each one. But since it's a rectangle, we can assume that JM is congruent to KL, and we can assume that KJ is congruent to LM. So let's set these up. Our horizontal distance from L to M is about 3. And our vertical distance is about 1. For JM, our horizontal distance is about 2, whereas our vertical distance is about 1, 2, 3, 4, 5, 6. So we have quite the difference here. But again, we only have to find it for 2 sides since we know that we have congruency here. Save yourself the work. If you can find a way to do less work in math, make sure you do it because there are shortcuts allowed to you. Let's set up the next equation. So the distance for LM is equal to the square root of your horizontal distance of 3, so 3 squared, plus 1 down, which is -1. So +3 plus -1 squared. And then next, we have a vertical distance of 1, 2, 3, 4, 5, 6. -6 since I went down. And I have a horizontal distance of 1, 2. To the left, so that'd be -2. So set that up below as well. You should have JM is equal to the square root of -2 squared plus -6 squared. Solving for LM first, your radical should look like this, with 3 squared being 9, and -1 times -1 being a +1. And if I continue to simplify, that'll get me the square root of just 10. And again, when we're working with these formulas on a coordinate plane, it's best we get them as a decimal. So we have to find the square root of 10, which is about 3.16 when rounded to the 100th. Same thing goes for JM. For JM, when I solve for the exponents, I'll have -2 times -2 to get 4, and -6 times -6 to get 36. Which means that when I add those together, under the radical, you should have about 40. And if I were to take the square root of 40, that would be about 6.32 when rounded to the 100th. So again, that means LM is equal to 3.16, but KJ is also equal to 3.16. And if JM is equal to 6.32, then LK is equal to 6.32. Now that we've found all the distances, your perimeter is the easiest to go off of. So, the perimeter will be LM plus JM plus KJ plus LK, which is 3.16 plus 3.16 plus 6.32 plus 6.32. And adding all those together, your perimeter will equal 18.96. That is your perimeter, 18.96. So for your area, it is a rectangle. So we're going to be working with the base times height formula. So we need to be multiplying JM times LM. So you should have 3.16 times 6.32. And when those are multiplied by each other, you should get about 19.97. So close in value to your perimeter, but not all the way. Be careful with your math and don't assume anything. That would be your answers for this rectangle. Moving on to the last two examples, we have the area and perimeter of another triangle. Draw your coordinate to match up with this. Your W is -5, 6. Your H is -1, 1. Your S is -1, 6. Draw out your coordinates on your own graph and give yourself a little bit of room into the negatives as well. So W is at -5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and up 6, 1, 2, 3, 4, 5, 6. Mine's going a little bit high, but that's okay. We'll do this in a different color. That'll be my W. H is at -1 and +1. And S is at -1, +6. So you actually have a right triangle here. So I can actually count two of these. I can already say that the measurement of side WS is equal to 1, 2, 3, 4, 5. The measurement of SH is equal to 1, 2, 3, 4, 5. But we do not know WH, which means we have to again use the Pythagorean theorem. So the measurement of WH is equal to the square root of 5 squared plus 5 squared. So it's equal to the square root of 25 plus 25. You should get the value of the square root of 50. Now the decimal of the square root of 50 is about 7.07 when rounded to the hundredth. Now we have every single measurement. This one is actually an easier triangle problem. We only had to use the distance formula once, and our area formula will be reliant on WS and SH. So for your perimeter is WS plus SH plus WH, which means your sum is 5 plus 5 plus 7.07. In total, the perimeter of the full shape of WSH is about 17.07. Again, with no units since we were not given any. So for the area, again, the area is going to be reliant on WS and SH because we can declare this side to be my base and this to be my height if I so chose. If you would like to, you are more than welcome to work with WH as your base, but if we can avoid the decimal, we typically will. Stick with your whole numbers if you can, which means for the area, I have 1/2 my base of WS times my height of SH. So 1/2 of 5 times 5, which means you have 25 divided by 2. 25 divided by 2 is about 12.5 for the area. This one, again, is easier than the last triangle one we did. Finally, we're going to be working with another rectangle. Our last rectangle has 4 points. We have G at 2, 2, B at -1, 3, P at -2, 0, and U at 1, -1. Draw your coordinates out on your own graph and see what shape we have. I am calling it a rectangle, but when you see, when everything's graphed, it's also known as another shape. This is actually a square as well. So since we have a square, we actually have, again, less work that we need to worry about. BG is congruent to GU, which is congruent to UP, which is congruent to PB. Every side here is congruent to each other, which means that I only need to find the distance of one side. So starting with that, my vertical distance for P is -1 since I had to go down 1, which means that my horizontal distance from P to U is about 3 since I went to the right 3. Setting that up, I have PU is equal to the square root of -1 squared plus 3 squared. -1 times -1 is equal to +1, and 3 times 3 is equal to 9. So you should have the square root of 10 as your value. Now the square root of 10, as seen in earlier examples, gets us a value of about 3.16 when rounded to the 100th. This is important though. You're done with finding distances, because if PU measures to 3.16, that means that BP is equal to 3.16. That means that BG is equal to 3.16, and that means that GU is equal to about 3.16. All sides should be equal to each other. So let's start finding our perimeter. The perimeter is all sides added together. So you should have PU plus BP plus BG plus GU, which is equal to 3.16 plus 3.16 plus 3.16 plus 3.16. Your value, when all of those are added together, is about 12.64. That is your perimeter. Now if we were to do the area is side squared when it comes to a square. So if it's side squared, that means that I have to do 3.16 squared to find my area. 3.16 times 3.16 gets me a value of about 9.9856. and that'll be your value. In all, that is how we do coordinate geometry, using the distance formula to help us find area and perimeter of these different shapes.